Hello and welcome to lesson 9-5. We're subtracting fractions again with like denominators. Today we'll use our understanding of subtraction as separating parts of the same whole to subtract fractions with like denominators. We're on page 349 in your Envision Volume 2 textbook. We're going to start with solve and share at the top. Leah and Josh live the same direction from school and on the same side of Forest Road. Leah's house is 8/10 of a mile from school. Josh's house is 5/10 mile from school. How much farther does Leah have to walk home when she reaches Josh's house? Solve this problem any way you choose. All right, we're going to have, we're going to draw a picture here with school here. And Leah's house being here. Okay, so Leah's house is 8/10 of a mile from school. Josh's house is 5/10 of a mile from school. All right, so we have to make this, that means that a whole mile is going to be down here somewhere, isn't it? If this is school, it's not even a whole mile away. Leah's house is 8/10 of a mile from school. This would be our 1 mile. And Leah's house is over here, 8/10 of a mile from school. Now Josh's house is only 5/10 a mile from school. So if here's school, let's count back. 1, 2, 3, 4, 5. So this would be Josh's house. So let's just count. That's 5, 6, 7, 8. That's where we get the 8/10 from Leah's house to school. We should have counted that to double check. 1, 2, 3, 4, 5, 6, 7, 8. All right, and then we're Josh is 5/10 from school. So, how much farther does Leah have to walk home when she reaches Josh's house? So she's coming from school to her home. So if she walks to Josh's house, how much further does she have to walk to get to her home? We can count 1, 2, 3, and of course these were tenths of a mile. That didn't change. We kept the same unit, the same amount. We divided it into 10 equal parts this whole mile. So what our problem was is we started at 8/10. We took away the 5/10 that she walked, because her house is 8/10 away from school. She walks 5/10 to Josh's house. How much further does she have to go to her house? So we, in our picture here, we found that it was 3/10. We can look at this and also see that 8 take away 5 is 3. So our answer would be 3/10 of a mile. That's how much further she has to walk. All right, let's go ahead and show you what you're going to sneak peek of what the visual learning video is going to be like. How can you subtract fractions with like denominators? You're going to use a number line, and you're going to use the bar and see 2 more examples using like denominators of subtraction. We will take a look at what we didn't do an example like this, that you're going to use the bar notation. So let's do these problems up here in a similar fashion so that you know what to do in independent practice. So when we are subtracting fractions, our whole, what we're starting with, is going to be represented by the line here. How much we're taking away is the part of the bar that we're going to be removing. So Jesse has a bottle that contains 7/10 liter of water. He drinks 2/10 liter. Jesse says he has a half a liter left. Is he correct? Let's take a look. So our whole, what we're starting with, is 7/10. If this is 7/10 and we take away 2 of these 7 equal parts, 1, 2, so this part would be removed from this part. How much do we have left? Because this is our 2/10. 2, let's see. So we're going to have to divide this up. 3, 4, 5, 6, and 7. So let's double check. 1, 2, 3, 4, 5, 6, 7. And we've taken away 2 of those parts, so we have 1, 2, 3, 4, 5 tenths left. So Jesse has 5/10 of a liter left. Is that the same as a half liter? Well, that's a very good question. If I have 10 equal parts of something, and 5 of them are gone, how many would I have left? 1, 2, 3, 4, 5. So yes, 5/10 is equal to 1/2. We could say this is 1/2 because, and this is 2 halves make a whole, right? This is the same size, the same amount as the other half. So 1/2 would be correct. What addition sentence can you use to subtract 4/10 from 9/10? So 9/10 take away 4/10 would be the subtraction problem, but it wants to know what addition sentence could we use to subtract that. So we would need to know what plus our 4/10 would equal 9/10. Remember, in a previous lesson I had told you that you can check yourself a subtraction problem. Last time I told you that take the answer and add it to what you subtracted, and you would come up with what you started with. So that's this here. We don't know how much this is yet, but that our answer to a subtraction problem plus what we subtracted would equal what we started with. All right, let's subtract the fractions up here. 2/3 take away 1/3. So using this notation down here, which you do not have to do, but which I'm just going to show you again, if we start with 2/3 and we take away 1/3, how many do we have left? See, this bar is representing the whole. 1, 2, 3. Whoops, and I did not do that correctly. We don't want to start with a whole. We're only starting with 2/3. So if we start with 2/3, we have 2 equal parts. This is our 2 equal parts, and one of them we're taking away. How many do we have left? That's right, we have 1 part left. But we've got to keep in mind our denominator did not change. So it's not 1/2, it's 1/3 because the whole was thirds. 3/4 take away 2/4. If you feel more comfortable doing what we did yesterday with just simply drawing a bar with fourths, shading in 3, 1, 2, and 3, Taking away 2 of those, 1, 2, we're left with 1 out of 1, 2, 3, 4 parts, or 1/4. 5, 6 take away 2, 6. Here's another way, just subtract your numerators. 5 take away 2 is 3, and carry over your like denominator, 6. 9 take away 3 is 6. Bring over your 12, the denominator stays the same. Here's a tricky one. 1/2, take away 1/2. Can be tricky. Here's 1/2, right? If we take away this 1/2, how much do we have left? That's right, we would have none. If you have a half of a pizza and you eat half the pizza, you have none left. All right, you are going to do 11 through 18. You do not have to do this diagram down here if you choose not to. Simply use the bar we did yesterday, or the subtraction of numerators carrying your denominator, or you're welcome to use a number line, however you see fit for 11 through 18. And then on page 352, numbers 22 and 23 on the back.